Hello everyone. So in today's video we are going to be talking about mechanisms which are present in our body for controlling blood pressure. So arterial blood pressure is regulated within a narrow range to provide perfusion of the tissue without causing any harm to vascular system. So perfusion of the tissue means every tissue needs oxygen, and for oxygen there is presence of blood, and through blood we provide oxygen to every tissue which is present in our body. If there is no oxygen, the tissue will ultimately die. So every tissue needs supply of oxygen through blood. So if we talk about the arterial blood pressure is actually directly proportional to cardiac output. It is also directly proportional to peripheral resistance. Now, what is cardiac output? Cardiac output means that how much output is given by your heart, which means how fast your heart is beating, what is the frequency, what is the force with which heart is pumping blood to the body. And if we talk about the peripheral resistance, as the periphery mean away from the center of the body, so it means vascular system is having the resistance in itself, and as there is increase in the resistance, there will be increase in the blood pressure. And how it is caused? If there is increase in the diameter of the blood vessel, there will be less of the resistance, so blood pressure will be less. But if there is narrowing of the blood vessel, there will be more of the resistance caused by walls of the artery, and therefore there will be increase in blood pressure. And same goes for heart cardiac output. If there is more force applied by the heart to pump blood, more of the contractions, and there will be more of the blood pressure, because if heart is pumping like this, there will be much more blood supplied to the body and there will be increase in blood pressure. But if your heart is pumping like this, obviously there will be less force and less frequency of cardiac output. So what it means is that there will be decrease in blood pressure. So this is how both of these things work. So cardiac output and peripheral resistance are controlled mainly by two overlapping control mechanisms. And what are those mechanisms? We are going to be talking about them in this video. So first mechanism for controlling blood pressure is baroreceptors and sympathetic nervous system. And second one is Renin-Angiotensin-Aldosterone system. So first of all, we are going to be talking about this control mechanism, which is Baroreflexes or baroreceptor and sympathetic nervous system. There are baroreflexes which act by changing the activity of sympathetic nervous system. So therefore they are rapid moment to moment responses. So these are fast and rapid kind of responses for the regulation of blood pressures. This is not something long term. This is short term and rapid responses. For example, if there is sudden decrease in the blood pressure, what will happen? If there is sudden decrease in blood pressure, what will happen is that there is cause of activation of pressure sensitive neurons, which are called as baroreceptors. Baroreceptors are actually pressure sensitive neurons which are present at different sites, such as they are present on aortic arch. They are also present in carotid sinuses. So when these pressure sensitive neurons are being activated because of the sudden decline in blood pressure, what happens is that these pressure sensitive neurons send impulses or signals to cardiovascular centers, and cardiovascular centers are present in spinal cord. So there is decrease in the blood pressure. What will happen? Baroreceptors are now being activated, which are present in aortic arch or carotid sinuses. So their activation will cause signaling to the cardiovascular center present in spinal cord. So in spinal cord there is presence of several centers which are known as cardiovascular centers. So these centers are being activated due to signal which is being sent by pressure sensitive neurons, also called as baroreceptors. So this reflex response causes increase in sympathetic nervous system or sympathetic responses. And what happen in sympathetic responses? We have learned in junior classes or in junior grades that when there is activation of a sympathetic nervous system, what actually happen is that there is cause of fight or flight responses, that there is increase in blood pressure, there is increase in cardiac output, there is increase in peripheral resistance, and there is in dilation of people and all other effects which are being included in sympathetic responses. So now this cardiovascular center causes sympathetic nervous system to be activated. Now as this sympathetic nervous system is being activated, what will happen? There will be increase in cardiac output and increase in peripheral resistance, and both of these things will ultimately lead to increase in blood pressure, which we have talked about over here, that both of these things are directly proportional to blood pressure. So if these things are being increased, ultimately there will be resultant increase in blood pressure. So as there is increase in sympathetic responses, it means there is actually decrease in parasympathetic nervous system or parasympathetic responses, which are decrease in cardiac output and decrease in peripheral resistance. So now this is being decreased and sympathetic responses are being increased, because both of these systems are actually working at the same time. If there is increase in one system, there will be ultimately decrease in the other system. So this is how it actually works. So when there will be peripheral resistance, what it means? Peripheral resistance is actually vasoconstriction, and vasoconstriction is actually causing resistance for the blood to flow, which will ultimately cause increase in blood pressure. An increase in cardiac output means that heart will pump blood more efficiently and more forcefully and with more frequency, and this will ultimately compensate the decrease in blood pressure, which was the initial stimulus for the activity of baroreceptors. So this is how baroreceptor and sympathetic nervous system show their response in decreased blood pressure. If we talk about the second mechanism which is being present in our body for the compensatory mechanism. The mechanism which we have talked about previously is actually for rapid or moment to moment response for the regulation of blood pressure, whereas the one we are talking now is actually long-term response in low blood pressure or in controlling blood pressure. So it is actually long-term control of blood pressure by altering blood volume, because here only cardiac output and peripheral resistance is being changed, which is resulting into changes in blood pressure. And same will happen in the opposite case. If there is increase in blood pressure, that will ultimately cause the peripheral nervous system to be activated instead of sympathetic nervous system. This will go both ways. So if we talk about this system, that is Renin-Angiotensin-Aldosterone system, this is actually long-term controlling mechanism, and because it works on the principle on changing or altering the blood volume. As there will be more blood volume, there will be increase in blood pressure, but if there is less of the blood volume, there will be decrease in blood pressure. So this is how it actually works. There is also presence of baroreceptors in kidney, which are actually pressure sensitive neurons. So when there is decrease in arterial blood pressure, what happens? These baroreceptors are being activated, and when these blood pressure sensitive receptors are being activated, what they does is that they cause the release of an enzyme which is called as renin. These baroreceptors cause the release of renin in case when there is reduced arterial blood pressure, and when there is activation of sympathetic stimulation, that is beta 1 adrenoceptors. In both of these conditions, there will be ultimately release of an enzyme which is called as renin. When there is release of this renin enzyme, what actually happens is that there is conversion of angiotensinogen into angiotensin I. So it is actually a converting enzyme. Angiotensinogen is converted into angiotensin I, and when this renin enzyme convert this into angiotensin I, this angiotensin I is further converted into angiotensin II by the activity of ACE, that is angiotensin converting enzyme. And now this angiotensin II is actually a very potent vasoconstrictor. So what it will do now, it will cause the constriction of vessels. It will cause the constriction of both arteries and veins, resulting in increase in blood pressure, because there will be increase in peripheral resistance because of the activity of vasoconstriction. When there will be vasoconstriction, there will be cause of increased peripheral resistance, and increased peripheral resistance actually cause the increase in blood pressure, as we have discussed earlier, because peripheral resistance is directly proportional to blood pressure. This angiotensin II exert a preferential vasoconstriction action on the afferent arterioles of the renal glomerulus, and thus it increases the glomerular filtration. And how this happen is that, as we know, if this is the structure of Bowman's capsule, and over here there is afferent artery which is coming over here, and it is now converted into smaller arteries, capillaries, and then it is being converted back into efferent artery. This is the efferent one, efferent arteriole, and this one is afferent arteriole. Over here, what actually happened? This afferent arteriole is actually greater in size, whereas this efferent arteriole is smaller in size or smaller in diameter. What will happen that when this wider artery is converted into smaller, what happens? There will be increase in the pressure. When water is passing through a wider pipe, it has less pressure, but when it passes through smaller area, it suddenly have increased pressure. So same happen over here, that there is increase in pressure because of change in diameter of the arterioles. So this change in pressure will cause filtration, because now there is more of the pressure and more of the particles will be filtered out because of the pressure being increased. So what actually happened over here, this angiotensin II preferentially constrict this efferent arteriole, as it is already having less diameter than afferent arteriole. When it is further constricted, what actually happen is that there is much more increase in pressure, which ultimately increase the filtration rate, GFR, that is glomerular filtration rate. Furthermore, this renin is also being increased or also being released because of low sodium intake or greater sodium loss, because this is also a stimulus for renin release. So we can write over here that this renin is also being increased. Other than this decreased arterial pressure and stimulation of beta 1 adrenoceptor, it is also being released because of decreased sodium intake or increased sodium loss. Both of these conditions actually facilitate the release of renin, and this renin ultimately causes the conversion of angiotensinogen into angiotensin I, which is ultimately cause the formation of angiotensin II, which is actually potent vasoconstrictor, and this vasoconstrictor cause increase in peripheral resistance, which ultimately cause the increase in blood pressure. This aldosterone secretion is stimulated by angiotensin II, which lead to increase in sodium reabsorption. When there will be more reabsorption of sodium, there will be increase in blood pressure. So it causes the increase of sodium reabsorption. It also causes increase in blood volume. which contribute to further increase in blood pressure. These effects of angiotensin II are mediated by stimulation of angiotensin II type 1 receptors. So, these stimulations are being activated by angiotensin type 1 receptors. So I have found this flow chart very helpful in understanding both of these mechanisms. Let's revise over here what is the function of these two mechanisms which are being present in our body for the controlling or regulating blood pressure. So when there is decrease in blood pressure, what actually happens that there is increase in the sympathetic activity. It is sympathetic nervous system is being activated, which cause the activation of beta 1 adrenoceptors which are present on the heart, that is aortic arch. So this ultimately cause the increase in the cardiac output. And when there is activation of alpha 1 adrenoceptor on smooth muscle, it cause increase in venous return. It also cause increase in peripheral resistance, that it cause the vasoconstriction. So both of these effects are causing three things, that is increase in cardiac output, increase in venous return, which ultimately cause more of the blood back to the heart, which will pumped by the heart later. And peripheral resistance is also being increased. So all of these factors are causing increase in blood pressure. And the third thing, there is presence of baroreceptors on kidney 2, that is beta 1 receptors, and these beta 1 receptors actually release renin enzyme, which cause the conversion or formation of angiotensin II. And this angiotensin further cause vasoconstriction because it is a potent vasoconstrictor, and it preferentially will have vasoconstrictor action on efferent arterioles of the renal glomerulus, and thus it causes the glomerular filtration being increased. So this ultimately causes increase in blood pressure. If we talk about the other system that happened because of the decrease in blood pressure, that is renal blood flow being decreased because of the decrease in blood pressure. So this decreased renal blood flow caused the increase in the production or release of this enzyme, which is called as renin. So when there is increase in the production of this enzyme, there will be increase in the conversion of angiotensinogen into angiotensin II with respective steps, and this will ultimately cause peripheral resistance. This will cause increase in blood pressure. Not only this, angiotensin II also cause the release of aldosterone, which actually cause sodium and water retention, which cause the increase in blood volume. And now when blood volume is being increased, there is increase in the blood pressure. So there is increase in blood volume, which will ultimately increase the cardiac output, and this cardiac output will ultimately cause the increase in blood pressure. So when there is decrease in the renal blood flow, what happened that the glomerular filtration rate was being decreased, and this decrease in glomerular filtration rate caused nephron to reabsorb more sodium and water back into the body, so that there could be increase in blood volume, and this blood volume will ultimately cause cardiac output to be increased, and this cardiac output When this cardiac output is being increased, it causes the increase in blood pressure. So this was the whole thing, how both of these mechanisms, that is sympathetic nervous system and Renin-Angiotensin-Aldosterone system, work together. Both of these mechanisms are two overlapping control mechanisms for the regulating blood pressure. So this was all about it. If you have any question, let me know in the comment section below. And thank you for watching my videos.